Opties! Today we're going to look at some Khan Academy in the solid geometry unit. I'm going to work through a few problems of a few different types of assignments, and we are going to start with apply this special person's name's principle. So I struggle saying this word. So I first said Cavalieris, but then I listened to some other people and they said, let me see if I can say it. Cavalieris. So it's probably Cavalieris. And I think about it as two parts, the Cavalier and then Aries. So, but that's a little fun for today. Let's look at this question. The following figures all have the same height, which is really important. So all have the same height. I'm going to underline that. And the same base area. So this Cavalieris person, this principle that they have says that if you have the same base area and you have the same height like we have here, then the volumes are equal. So we have A, B, and C. Notice that the shape of the base for C is different than the shape of the base for B and A. However, they do have the same areas, which is what the principle goes off of. Not the same shape, but the same area. For which of these figures can we apply Cavalieri's principle to show they have the same volume? So we just discussed that since they all three have the same height and base area, that it should be all of them. So let's check it. And we're correct. Let's do one more on this assignment. Okay, so next, consider the following right pyramid, so that's this dude, and right prism, this guy. Both figures have a base that is a regular pentagon. So it's saying the bases are the same shape, basically. So same shape. We don't really know yet about the same area. So we've got same shape. What about the same area? That's what we need to know for Cavalieri's principle. Same area and same height. We can see visually they have the same height. It's labeled. Let's see what Heidi says. So Heidi tried to use Cavalieri's principle to show that the two figures have the same volume. This is what Heidi says. The base areas are the same. Therefore, corresponding cross sections have the same area. The figures have the same height, so the volumes must be the same. Seems like a pretty good explanation. Let's verify, though, that they do have the same area, because that was our question. Since they're both the same exact shape, and the only thing you really need to define the size or the area of a regular pentagon is a side length, because regular means all sides are congruent and all angles are congruent. So any pentagon has all the same angle measures if it's regular. So we're good on the angles. The side lengths here, they're both 1. So we don't even have to calculate the area to know that they are having the same area here. So yes, Heidi looks like they know what they're doing. So let's see, what mistake did Heidi make? Maybe there is an error. Before I looked at the answer choices, I was thinking maybe there was one that said there is no error. So let's read it again. Notice that, my initial thinking was not true. That's okay. It's called problem solving. It's called looking at things and making sure that we're addressing all the situations. So let's see. Oh, I'm so silly. I am so silly, y'all. And I'm sure you probably saw this from the beginning. The heights and the base areas are the same. Well, yes, the base areas are the same. However, not each cross-sectional base area. What that means is if I go up, maybe let's go to a height of 1, so in the middle. Here's the shape of this pentagon at a height of 1, kind of in the middle. And then this pentagon is much smaller. So like the pentagon of the left one is like that big maybe. The pentagon of the right one is like that big. Definitely not equal areas, right? Even though the bases are. It has to be each cross-sectional base. So the base areas are the same. That's not A. It isn't true that corresponding cross sections have the same base area or same area. Yes, that's what we're looking for. So let's see in what part of Heidi's explanation we should rule out as being incorrect. The base areas are the same. That's good. Therefore, corresponding, well, this is not true. Just because the base areas are the same, that doesn't mean that corresponding cross sections have the same base area or have the same area. I don't have to say the word base there. So that's it. The heights are the same. We see that here. So that was another check. So got to check those cross sections. A general way to see this is that they're not the same solid, right? They're not the same type of solid. One of them is a pyramid and one of them's a prism. What is true is that this dude is 1/3 the volume of that prism with congruent height and base area. Okay, moving along, we'll check, and we're correct. The next assignment we are going to look at today is use related volumes. This one's really interesting, lots of different interesting types of problems here. So let's dive into this first one. It says, the following cylinder has a volume of 55 pi cubic units. So cylinder, let's go ahead and write that in our picture. Volume is 55 pi units cubed or cubic units. A little bit of difficulty there with my N and my 3. There we go. And a height of 5 units, which we can see. Let's go ahead and put equals H. The cone has the same base area and height. Okay, we definitely know some relationships with the same base area and height of a prism-like figure to a pyramid-like if they have the same base area and height. So that's going to be interesting. And it has a slant height of 6, which we see. What is the volume of the cone? Okay, so the relationship here, again, because of these two things, same base area and height, because of those two things, the cone is 1/3 the volume of the cylinder. If you would like to understand why this rule applies between a cylinder and cone, or let's say a square prism and a square pyramid of the same base area and height, you can check out some other videos I've created. So the volume of the cone is, all you have to do is 1/3 of the volume of the cylinder, which we already have. If you wanted to write it in terms of words that might help you, you can write volume of cylinder. Sometimes when I do that big V for volume, I draw a picture instead of saying a word. So we just calculate this, and we see that it's written real nice for us here. We don't even have to really type anything in our calculator or do any computation here. We just see the 55 and the 1/3 together here, like the 55 thirds. And our answer's in terms of pi all ready for us, meaning pi is written as part of our answer. So let's check. And we're good. Let's do some more on this assignment. Use related volumes. So this next question says, the following square-based pyramid. So this is the square-based pyramid. Let's underline color code there. Has a base area of 30 square units. So let's write that in. 30 units squared. I'm just going to do UN for units. Here's my little squared. Let's fix it. There we go. And a volume, so big V here, of 96, of course, cubic units. The cone has the same base area and height. Okay, what's the volume of the cone? Well, this is Cavalieri's principle. Same base area and height if they're both the same type of solid, essentially. It's one way to think about it. This is not a pyramid versus prism type situation. So even though the bases have a different shape, really it amounts to their area. So their volumes should be equivalent. So we're going to choose the 96 cubic units. And check. Let's do another problem on use-related volumes. This assignment has lots of different types of questions, so it's good to do several. Let's read this one. Prism A has a volume of 60 cubic units. So prism A here is this one, so 60 cubic units for volume. And a height of 12 units. We need to write that in because, well, we do see it over here. It's just kind of far away. I'll write it over here as well. Just to see it well. Okay. Prism B has the same base area and height, but a length of 15 units for its longest edge. This 15, its longest edge, we could also call the slant height. Slant height does not really concern us when we're thinking about formulas for volume, or in this case, when we already know they have the same height, because height is what we use to determine volume, not a slant height. So we really don't even need our 15. We don't really have to do any computation here. We just have to reason through the situation. What is the relationship between the volumes? This is another example of Cavalieri's principle. Same base area, same height. They are both the same family of solids. They're both prisms. So just because it's slanted does not change the volume. So their volumes are equivalent. So let's check. This looks a little bit more, maybe a little bit different than ones we've seen before. Cylinder A has a radius R, height H, and a volume of 10 pi cubic units. Definitely want to write that in our picture. So volume is 10 pi units cubed, or cubic units. It's my crazy little 3 there. Let's fix it. Cylinder B has twice the radius. So we see our 2R here, and twice the height, 2H. What is the volume of cylinder B? So there's probably several ways you can think about this. One thing I might want to do is look at the volume of A, meaning this cylinder A, and write it out. So the volume of a cylinder is the area of the base, which is pi times radius squared, because it's a circle, times the height. So let's substitute what we know. 10 pi is the volume, and then we just have a missing radius and a missing height. Now let's write the formula for the volume of cylinder B. All we know is that the radius and the height is double. So we're going to put 2R and 2H. Now, let's simplify here. 2R squared is the same thing as 2R times 2R. And we still have our 2H. Continuing, we have 2R times 2R is 4R squared. And we still have our 2H. Continuing again. Let's take care of these two numbers. Pi is a number as well, but the, let's say whole number pieces. 4 times 2 is 8. And we have our R squared and our H. So now, one more thing you could do is bring the 8 out front. That might help you visualize things. Now let's analyze, because now we have pi R squared H and pi R squared H in both of our volume formulas. So what that means is that the volume of the second cylinder, volume B, it is 8 times the volume of cylinder A. 8 times. So all we have to do is multiply the volume of cylinder A by 8. So volume B is 8 times the volume of A. Essentially, this right here could be rewritten as the volume of A. We could do some substitution there because they They have the exact same expression there. Okay, so volume B is 8 times volume A. Substituting for volume A, which is 10 pi, we get 80 pi. And of course, that's cubic units. So D. Nice. Lastly, let's look at some questions from volume of prisms and pyramids. This assignment gives you lots of different questions of different types of solids, which I love because you have to, practice making the correct volume formula decision. So it's good to have it mixed up. I have a formula sheet that you can use that has all the formulas for the pyramids and pyramid-like solids and prism-like solids. Let's go ahead and look at this one. This trapezoid-based right prism has a volume of 30 centimeters cubed. What is the area of the base of the prism? So let's make sure we know what it's asking for. The area of the base of the prism is asking for the area of the trapezoid. So either this one or this one. They're both congruent. Bases of a prism have to be congruent. So we're only finding the area of one of those. Let's go ahead and write the volume formula for a trapezoidal prism. So starting with the volume of any prism, the volume is the area of the base times height. Notice that in these set of parentheses, that is our question, area of the base. Base meaning base of the prism. So that's our question mark. Or we could name it X or whatever you'd like. I'm gonna say question mark. That way we don't have to look at a whole little phrase for our variable. And I'm actually, instead of writing height, I'm just gonna keep it as H. Now we can substitute. We know the volume is 30 centimeters cubed, or for now, I'll just write 30. And our height is 5. Now we want to find the area of the base. So we're just solving this equation for the question mark. So since question mark is getting multiplied by 5, we do the inverse operation of multiplication, which is division. Do it on both sides of the equation. That simplifies to 1, or 1 question mark, and 30 divided by 5 is 6. We cannot forget our units. Area is in square units, so 6 units squared, and the units here are centimeters. So 6 centimeters squared. The unit is already written for you. However, it's good to think about that when we're writing it out in our solving. So 6 and check. Let's do one more problem. I like this one because it is prism-like, and it's not just a plain old cylinder, which is the most typical prism-like solid we see. It's actually a piece of a cylinder. So let's read this in its entirety. Each base in this right prism-like figure is a quarter means 1/4, of a circle with a radius of 2 meters. We notice we have our radius marked visually. Let's go ahead and put an R there. We could have written equals. I'll do that as well. You might like the way that looks. And our 10 is going to be our height. So it's just asking us for volume. And we want to leave in terms of pi. Exact answer in terms of pi. So let's write out the formula for a regular cylinder. That might help. There's kind of 2 ways to think about this. You could just do the formula for a prism/prism-like figure as area of the base times height. And then you could just take the area, the fourth part has to come into play somewhere. You can either apply that to the area of the base section, or you can think about it as finding the volume of the entire cylinder if it were there, and then just taking 1/4 of that entire volume. In my experience, students have preferred the second way, so let's think about it that way. So the volume is area of the base times height. The area of a cylinder is or sorry, the area of a circle, which is the base of a cylinder, is pi r squared. R is radius, times h for height. And since we are doing a quarter of a circle, which means a quarter of our cylinder, we're going to divide by 4. You could also multiply by 1/4. It's the same thing, whichever you prefer to think about it as. So let's substitute. We're wanting to find the volume. That's our missing variable. We have our pi. Our radius is 2. Our height is 10. We're dividing by 4. So we're going to keep on simplifying. We have our pi still. Let's take care of our 2 squared. 2 squared is the same thing as 2 times 2, which is 4. And we're having times 2 times 10, dividing by 4. So some options here. You could just go ahead and make this a 40, which would give you the 40 pi as the numerator. And then you could think 40 divided by 4 is 10. Or you could notice that there is a 4 in the numerator and the denominator, and everything's getting multiplied in the numerator. So you can just go ahead and realize that this simplifies to 1, which also gives you the 10 pi. Now, when it says give an answer, exact answer in terms of pi, that means you do not want to multiply by pi with your calculator. You do not want to get an approximation. You don't want to get a decimal, basically. You want to leave it just like this. You're finished here, except for units. So let's go ahead and write our units. Meters, and its volume, so it's cubed, which we see here written for us anyhow, but it's good to practice units. So we have our 10, and we click our pi button. And let's check. Here we go. All right, Opties, I hope this was helpful, and see you next time.